Hello, welcome to Spy Math. This is Mr. Spy, and this will be the final video of the 6 videos series on the June 2018 Geometry Regents, Part 2, questions 25 through 32. Let's begin. Question 25. Triangle A prime, B prime, C prime is the image of triangle ABC after the translation of 2 units to right and 3 units up. Is triangle ABC congruent to triangle A prime, B prime, C prime? Explain why. Now let's first draw a diagram of what's going on. So here we have triangle A, B, C, and it went 2 units to the right, and then 3 units up. So our new triangle is over here. A prime, B prime, C prime. There were no dilations, so the triangles keep the same size and shape because the translation is rigid motion. So our conclusion is as follows. Conclusion. Triangle ABC is congruent to triangle A prime, B prime, C prime. Hence a translation of 2 units to right and 3 units up is a rigid motion, and a rigid motion preserves size and shape. That's all you need to say. Say the translation is rigid motion, and make sure the word rigid motion. That's a full explanation. This diagram is not needed. It's a good visual representation, but we have no measurement of what a unit is, so you just move 2 and show us moving to the right and moving up. That's it. On to question 26. Triangle ABC and point D are graphed in a set of axes below. Graph and label A prime, B prime, C prime. The image of ABC after relation of a scale factor centered at point D. Now, this is a bit of a hard thing to do. Since D is not the origin, the only way you can dilate is by using the slope to dilate. By using the slope means you draw these cases I have here. You get a scale factor of 2. So you first do it for point A. And you notice the slope is 1 down and 3 to the right. So it's negative 1/3. So 3 across, down 1. 3 across, down 1. And there you get A. So the slope for A, D. So you want to put it down, slope A, D is negative or positive 1/3, based on which way you want to think about it. It's actually just positive 1/3. Going backwards. Then you do the same thing for D, which is up 3, left 1, up 3. Left 1, up 3, left 1, up 3, or 3, up, left 1. Either order will be fine. And you get to that. So that slope is negative 3 over 1. So the slope, important, the slope of BD is negative 3. And you need these for this one. And you do D to C. You go down 3, right 3. So the slope of DC is negative 1. There's many different ways of doing this. I think is the best way. You bind the points A prime, B prime, C prime. Make sure the primes are obvious. Mark off the points clearly and draw your triangle as I did. And it's a good idea, but not needed to. State the points at the bottom, just in case you made a mistake in the drawing, you could get credit for your points. So A, move from negative 2, 1 to A prime, which is negative 5, 0. B, move from 0, 5 to -1, 8. C moved from 4, -1 to C prime 7, -4. And our center the whole time was 1, 2. On to question number 27. Quadrilaterals BIKE and GOLF are graphed in a set of axes below. Determine a sequence of transformations that maps quadrilateral BIKE, quadrilateral GOLF. So a good thing to do is write the two names one above the other. So B went to G, I went to O, K went to L, E went to F, and track the movements of one point. In case I'm going to track the movements of B. So B went from -6 to B prime 6, -6 by a reflection over the y-axis. So I redrew my new quadrilateral B prime, I prime, K prime, E prime, and then it moved, translated up to 6, -1, which is our G. Now we need to write our sequence. So our sequence is as follows: reflect quadrilateral BIKE over the x-axis to map to get quadrilateral B prime, I prime, K prime, E prime. Translate quadrilateral B prime, I prime, K prime, E prime up 5 units to map to quadrilateral GOLF. Be very remember that it must be a reflection because B matches with G, and B and G are on opposite sides of the quadrilateral. On to question 28. In the diagram below, secants RST and RQP are drawn from point R. Intersect circle O at STQP. If RS equals 6 and ST equals 4 and RP equals 15, what is the length of segment RQ? So you let RQ or QR equal X. Mark off your diagram. TS is 4. SR is 6. That makes the whole length 10. Just going to put the whole length in there. It's 10. Okay. And the length of RP, which is whole length, is 15. The outer part, QR. So the formula is the external part of the secant marked off with E. The whole secant, S, E1, S1 equals E2, S2. So the external secant times the whole secant equals the external part of the secant times the whole secant. So 6 times 10 equals X times 15. 6 times 10 is 60. X times 15 is 50X. Divide both sides by 15. 15 times 15 is 1. 60 divided by 15 is 4. So X equals 4. So the length of QR is 4 units. On to the construction question. Using a compass and straight edge, construct the median to side AC, the triangle ABC below, leaving all construction marks. So our plan is to find the middle of segment AC, and then draw a point from the middle of segment AC to point B as our median. Let's pull up our construction program, and let's do it. Okay, so you take your compass, put it on point A, open it at the point C, and make an arc above and an arc below. Swing the compass, move it to the point C, do the same arc above and arc below. So you get this eyeball shape. Take your ruler, line it up at the bottom, eyeball shape, line up at the top, draw a line, do all this line in blue. There's a line just to find midpoint. It's not the construction yet. Draw a line to indicate midpoint. Right here, marked off in black, is the midpoint. Do a better marking. Right there. Black is the midpoint. We want to connect it to point B. So I'm going to draw this now in red, indicate it's the answer. Take our ruler again, line it up with the midpoint of segment AC, then line it up with the point of the vertex of angle B. Draw a straight line. Oops. Not getting a good straight line. One second. And sorry for that pause. You draw a line from midpoint of AC to point B, which is this line I just drew in red. Use your ruler. It's not an easy line to get on a digital program, so I had to pause for a bit. And maybe label it, because you'll have this extra line over here. I'm marking off in yellow. You don't want to be considered to be your median accidentally in the answer. And say this is the median of side AC, segment AC. And that's the it of question 29. It's construction. On to question 30. Sky says two triangles below are congruent. Margaret says the two triangles are similar. Okay? We have Sky and Margaret both correct. The answer is yes. Explain why. So if using the Pythagorean theorem, you can find at the missing sides of each triangle. First, in this first triangle, which has 5 centimeters and 12 centimeters for the legs, we'll have a hypotenuse of 13. And then you use the other triangle, which has a leg of 5 centimeters, a hypotenuse of 13 centimeters. That means the other leg has to be 12 centimeters. You could show your work for finding both the missing sides of each triangle using the Pythagorean theorem. So for the first triangle, we'll call triangle 1, 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. Square root of 169 is c squared. C equals 13. Be careful, even I make mistakes. 5 squared plus x squared equals 13 squared. For the second triangle, 5 squared is 25, 13 squared is 169. Subtract 25 on both sides. 169 take away 25 is 144. Square root of x squared is x. Square root of 144 is 12. So the missing side is 12. So each one of these is in centimeters. Now we have to actually write a conclusion. This gets you no credit finding the missing side. Just write this conclusion. Yes, both Sky and Margaret are correct. Triangles are congruent and similar. Since two triangles have all corresponding parts of triangles congruent, and the two triangles are congruent by the side-side-side triangle congruency. Also, any triangles that are congruent are similar because the corresponding angles are congruent. We either use angle similarity or side-side-side similarity. Therefore, both Sky and Margaret are correct because all congruent triangles are similar. I should get them to right. All congruent triangles are similar triangles. The reverse is not true. Okay, about to go to the last question in this section. As I meant before, this question is 31. 32 is part of the next section. Sorry for that mistake. On to the last question in this section, and last question for this reading set. Randy's basketball is in the shape of a sphere. So if you want to see what a sphere looks like, it's a circle, three-dimensional circle, usually drawn something like that. Not as good as I usually draw it. Do better drawing. Give me 1 second. Good drawing ways to draw like a circle, then a bowl below, and a bowl above. Sorry for my terrible drawing. Randy's basketball shape of a sphere with a maximum circumference of 29.5 inches, so a distance around the middle is 29.5 inches. This distance around the great circle. Determine the state of volume of the basketball to the nearest cubic inch. So we're starting out with circumference. We need to get a radius. So c equals 2 pi r. 29.5 equals 2 pi r. Divide both sides by 2 pi. Cancel the 2, cancel the pi. 29.5 divided by 2 pi is 4.695 inches. Then you plug that into the volume formula. Let's just make sure that our calculator, everything works out. So we take this 29.5 divided by, let's actually do it as a fraction, alpha y equals, to get a fraction, 29.5 over 2 pi 4.695. Now plug it into the volume formula. Alpha y equals 4 thirds times pi times our answer. So second, negative sign, give our answer. Close our parentheses, put that to the third power. Hit enter, and we get our answer for 33.526 cubic inches. When your answer rounds to the nearest cubic inch. So our final answer is 434 cubic inches. That's the end of this set of videos on the June 2018 Regents. If you liked this set of videos or you like any of these, please hit like below. Subscribe to this channel. There will be a lot more videos coming up this year on geometry, and most probably some topics on AP statistics. Sure, some topics on Algebra 1 and Algebra 2 and Algebra 1 and Algebra 2 Regents, starting with the June 2019 Regents, followed by the August 2019 Regents. The next Regents I will be doing is the August 2019 Geometry Regents, followed by the January 2018 Regents, and I'll be stopping January Regents for a while after that, Geometry Regents, and then going on to Algebra 1, Algebra 2 Regents. We'll be doing Algebra 1, Algebra 2, middle school, high school, and other class topics at request of commenters below or students that I have throughout the year. If you liked it, please comment below. And if you want me to put out any more videos on any high school, middle school, or college math topic that you think relates to this channel, please comment below. This is Mr. Spy, signing off.